Okay, taking a look at 404.2c, switch control lighting. Switches controlling line and neutral lighting loads must have a neutral provided at the switch location. This was a change in the 2011 code. Now, there's an exception to that rule. So the basic rule is you have to have, now 2011 code, you have to have a neutral at every switch location. Now, here are the exceptions. Now, let me give you some background here. This proposal was by Fred Hartwell, and Fred and I were together doing a seminar in Boston just a couple months ago, and he said, you know, Mike, I submit a lot of proposals, meaning Fred does. He says, and sometimes I'll submit a proposal that it'll get accepted. He says, and then I look at it later on, I realize, boy, I made a mistake. And I know I've done the same thing. And those of us that submit proposals, sometimes it gets accepted. We look back later on, like, that was a mistake. And the intent of this proposal is that when you have occupancy sensors and motion sensors or switches with pilot lights, sometimes these devices require a neutral. And if a neutral is not provided in the box, then what happens is the electrician starts using the equipment grounding conductor for the neutral, and then it creates some objectionable current. So that's the intent of this proposal. So it's a good intent. The problem is that the scope of 404 is switches. That would include, what do you call those switches on the closet doors, guys, that you kind of like open a closet? What do you call those kind of switches?
A little micro switch?
Micro switch? Well, that's a switch. So technically, you're supposed to bring a neutral to the little micro switch to a closet. Technically, a time clock is a switch. You're supposed to bring what? You're supposed to bring a neutral to a switch. And any switch being used for any circuit breaker being used for switches, you got to bring a neutral there. So the intent was never to bring a neutral to every single switch. The intent was to make sure that if you had a device box and you're going to be putting in a switch that would require a neutral, that a neutral be provided in the box. So that's the intent of the rule. And Fred was thinking about having what is called a tentative interim amendment, which is like a change of the code between the code change to fix this, because it was never intended to create a conflict with anybody. Now, Steve?
Yeah, I've heard this, and I guess maybe our engineers on the panel can help confirm it for me, because in our state, we're not involved with the energy code at all whatsoever,
Yes.
but many states are. Is it one of the intentions of the energy code that everything should go to occupancy sensors?
Victor, what's going on with energy codes?
The energy codes now are pretty much requiring occupancy sensors in particularly any commercial occupancies, yes. There are other ways of obtaining the energy savings that those energy codes are requiring, but they're all pretty much complicated ways of doing it and expensive ways, and so the occupancy sensor is the way to do it.
So you go to the switch, but occupancy sensor takes care of that.
Yeah.
Victor, as I go along, do a check in the UL White Book and see anything about these occupancy sensors, whether they require a neutral or whether they use the equipment grounding conductor as the circuit path. If you can check, see what the UL White Book says, because I need to know that. Because I think, Steve, that's a brilliant point you're bringing up, that a lot of these occupancy sensors need a neutral. There's no neutral. And so people are having some problems here. So let's get into the exception. Here's exception number 1. A neutral conductor is not required at the switch box if the raceway has sufficient area to add a neutral conductor. Meaning that, well, if you can pull a neutral in later on, well, then you don't have to bring a neutral now because you have a better raceway. So you can only bring a neutral if you need it. So that's a reasonable exception, and that should take care of most cases. A neutral isn't required at a switch to box. Here's another exception, number 2. With cable, if the framing cavity is open at the top or bottom on the same floor. Let me describe that one. That should be like a separate graphic, and we'll make a separate graphic on that one. That is saying that you have a commercial building, and we have a raised floor graphic, and we have a suspended ceiling. Because you have a raised floor, you have a suspended ceiling, and let's say the drywall on the bottom of the raised floor is not there. Can you visualize that, where you have a raised floor, and below the raised floor there's no drywall on the bottom of the partition? Mm-hmm. And then you have a suspended ceiling, and visualize where the drywall stops at the suspended ceiling portion. So above the suspended ceiling, there is no drywall. So read the rule here. A neutral is not required to switch device box wired with the cable if the framing cavity, that's the framing cavity, is open at the top or bottom on the same floor level, right here. So if we had a wall partition here and the drywall was open at this end here, well, then guess what you could do? Then you had a switcher. You can just bring a cable down and pick up the switch. if this is a raised floor and then you have the partition here and the drywall's open out here, you can pull a cable right up in that location. So that is the intent of this rule. So if you're in a commercial occupancy, in most cases there are suspended ceilings, and so in most cases, let's go. You're in a building that has metal raceway systems. Don Dale, don't worry about the switches. Okay, you're in a building, a commercial occupancy, that they're running MC cable. Well, if they're running MC cable, well, then you have no way to get the neutral inside the cable. So therefore, if there's an opening on the top and the bottom of that cavity, well, then you can pull the cable in. Then you don't need to have a neutralized switch. And the last opportunity is the same exception, but the next graphic, which we'll be showing this photo right here, is a neutral is not required at a switch location. We probably should show the inside partitions. That it's not required at a switch location if the framing cavity is through a wall, floor, ceiling. Okay, if it's unfinished on the wall behind the switch, unfinished below the floor, or unfinished above the ceiling. So this is not the best graphic that shows that, but it does show this point. If you have a basement and you show the inside partitions and you had a switch, well, you could add a neutral to this romex wiring in this house via the bottom. And if we showed a picture up on the attic here, since if this was open at the top here, the switches on the second floor have the ability to get a neutral added. So therefore, I don't need a neutral on any of these switches, even though they're wired with romex. So when does this become a problem? This becomes a problem when you have no access to the attic space, you have no basement, and there's no way to get wiring later on to that. So, well, when would that happen? Well, that would happen very common in Florida that have two-story homes, where the first floor is a monolithic slab, so we don't have a basement, so you can't get up the bottom. And then you have a second story, which means you have a first. So above the ceiling in the first floor, there's no way to get wiring because it's not unfinished above that. So if you have a two-story building and there's no open bottom, no open top, and it's not wired in a metal raceway, then those areas require a neutral to every one of those switches. Kevin.
This applies to three-way switches and four-way switches. But the good news is that if your wiring method is romex, romex is available 14-4 with ground and 12-4 with ground.
So you're saying, listen, Mike, if you're wiring a building and you're using a cable system and you don't have access from the unfinished basement, an unfinished ceiling in the bottom, and you don't have an access to the top, well, therefore, you have to bring a neutral to every single switch. You can get non-metallic sheath cable that has 4 wires.
Yes.
So it would be, let's see, what colors would it be? Is it 2 white wires and a black and a red?
No, that's a different product. It would be black, red, blue, and white.
Oh, black, red, blue, and white. So if I was going to do three-way switching, I would be able to use black for the feed to the switch, let's say, or the blue for the switch leg, whatever the case may be. Okay, so therefore, I'd have to get a cable for that application. So you got to be careful. 2011 code on this one. This could be hurting.